Write each expression as a single logarithm and then evaluate the expression. So if we take a look at A here, we have two logs that are being subtracted, and each log is preceded by a numerical coefficient. When we have this situation, this numerical coefficient that's in front of the log can be moved into the log and become the exponent of the argument. This is the log power law. So that means that in A we can rewrite this expression as log 2 log with a base of 2 of 2 to the power of 4 minus log with a base of 2 of 64 to the power of 1/3. Now, when we're subtracting logs that have the same base, in this case both logs have the base of 2, we can turn these logs, sort of merge them together using the quotient law, which means that the quotient log law, which means we get a single log where the arguments are going to become a quotient. So we can rewrite this as log 2 of 2 over 4 over 64 over 1/3. Now we can evaluate and simplify this quotient. So log 2. So 2 to the power of 4 is 16. 64 to the power of 1/3. This exponential form can be written as a radical. It can be written as the cube root of 64. And the cube root of 64 is 4. (16) divided by 4 is 4. So in this question, they want us to write each expression as a single logarithm. So here is that single logarithm. And then they want us to evaluate the expression. At this point, you could do this on the calculator, but I'm going to do it algebraically here. So I'm going to write log 2, log with a base of 2 of 4 equals to x. Convert this to exponential form, so it's going to be 2 to the power of x equals to 4. Rewrite the right hand side so it has a base of 2, so this can be written as 2 to the power of x equals 2 squared. And once the bases are the same, we can drop the bases and just write down the exponents, which says x equals to 2. In B, we are going to do the same thing we started with in A. This numerical coefficient 4 is going to be moved into the power position. So we're going to start with that. So we can write log with a base of 5 of 2 to the power of 4 minus log 5, log with a base of 5 of 16 over 5. We are here subtracting these logs, so we can rewrite them as a quotient. So I'm going to do two things in the next step. I'm going to apply the quotient law, so these two logs become a single log, where the arguments will be the quotient. And I will also evaluate 2 to the power of 4. So 2 to the power of 4 is 16. So we're going to get log with a base of 5. The numerator is going to be 16. And the denominator is going to be 16 over 5. Now we have a double quotient here. So we can rewrite this as log 5. So we can take the numerator 16, write it as a quotient, times, and then we take the denominator, which is 16 over 5, and we take the reciprocal of that. So it's going to be 5 over 16. So here 16 cancels, and we're going to be left with log with a base of 5 of 5. Now, whenever we take the log of an argument that is the same value as the base, this always equals to 1. So log with a base of 5 will be 1. Now we can do this algebraically as well, similar to in A. We would simply do log with a base of 5 equals to x, convert to exponential form. So it's going to be 5 from the base to the power of x equals to 5. And we can put a 1 here, the exponent is 1. Once the bases are the same, drop the bases and we get x equal to 1. And then finally C. So again, we're going to apply the power law. So we're going to move these numerical coefficients into the log, and they will become the exponents of the argument. So we can rewrite the following log expression as log 8 of 2 to the power of 8 plus log 8 of 0.5 to the power of 2. We can evaluate these two powers here. So 2 to the power of 8 is 256 plus log with a base of 8. 0.5 squared is 0.25. And so now we're adding two logs. The two logs have the same base. They both have a base of 8. So whenever we're adding two logs with the same base, we can rewrite this as a single log using the product law. So we're going to get log with a base of 8, and then we're going to multiply the two arguments, 256 times 0.25. And that's going to be 64. So this is our single log. They want us to evaluate this. So log of 8, log with a base of 8 of 64 equals x. Convert to exponential form. So 8 to the power of x equals 64. 64 can be written with a base of 8 as 8 squared. Drop the bases and we get x equals to 2.